Hello again. Welcome to another lesson in Algebra 1. Today we are covering section 9.1 on adding and subtracting polynomials. All right, so a warm-up was to simplify each by combining like terms. So we've done this before. So we have 2x plus 4x. Remember, since these are the same variable with the same exponents, we can combine them because they are like terms. And to add them, we just say 2 plus 4 for 6 and put the x back. All right, so for number 2, 2y plus 6y, same thing. We can add 2 plus 6 for 8 and put the y back. Okay, so remember, x's will only add with other x's and y's will only add with other y's. So if we get a problem like number 3, we may combine only the m's with other m's. So 8 plus 6 is 14m. And then we can combine the n's with other n's. So 4 plus 8 is 12n. All right. Number 4, the x's will combine with other x's. So 11 plus 8 will give me 19x. And then the constant term comes down by itself. So we get 9. And number 5, 9t minus 7t is equal to 2t. You do 9 minus 7 and put the t back. Okay. And number 6, we have only a 9 left by itself, so we put the 9 here. 5y minus 5y will go away. And then in number 7, these are m squareds, both of them, so we can combine them. But remember, there's a 1 in front of here, so that's 1 plus 2 for 3, and put the m squared back. Okay. In number 8, we have 2x squared plus 2x squared, so that's going to be 4x squared. And then 5x plus 3x is equal to 8x. On our second page, we have some review definitions here. All right, so we've been through these once this year. So first thing is a monomial. So a monomial is a number, a variable, or a product of one and more variables whose whole number exponents. So we can't have fractional exponents, we can't have negative exponents, okay? So we can only have positive exponents, and they have to have the variable in the top, not the bottom of the fraction, okay? So these are all monomials. 2, 3x, 2x squared, 3x squared, yz cubed. Okay. All right. So the degree of a monomial. Okay. So the degree of a monomial is the sum of the exponents of the variable in a monomial. So if we have 2 here, there are no variables. So that means that there is a degree 0 because there are no exponents. So you can think of it this. Oh, if it had an x in here as a variable, its exponent would have to be 0 so that it could turn into a 1. And then we have 2 times 1, which is still 2. Okay, so if it has no variables, then the degree is 0. All right, so our second one is degree 1 because this guy has a 1 exponent. Our third one is degree 2 because it has a 2 exponent. And then our last one is degree 6 because you add up the exponents on all the variables. 2 plus 1 plus 3, and that makes 6. Okay, so a polynomial. A polynomial is new one here. So this is a monomial or a sum of monomials. And each term of a polynomial, so each is called a term of a polynomial. All right, so the monomial that are all added together are the terms. So over here we have a monomial anyways, or a one-term polynomial if you want to call it that. Okay. Same with this one. So this is a monomial. So this is definitely going to be a polynomial. Here we have a polynomial. This one has 3 terms. Okay. And in the last one, we have a polynomial, and this one has 4 terms. All right. So now a polynomial also has a degree. So we're going to write the number of terms that each polynomial has. And we're going to write the degree of that polynomial. The degree of a polynomial works a little different than the degree of a monomial. So let's go through and we're going to do terms first. Okay, so that's just review. So our terms here, we have 1 term, 2 terms, and 3 terms. Okay, so our terms are 2x, 5y, and then negative 12. And that's because this is separated by plus a negative, so this really is an adding, and then the term is negative 12. So there are 3 terms here. In our next one, we have 1, 2, and then remember this is really plus a negative, so 3. Okay, a polynomial separated, terms are separated by adding. Okay, so this has 3 terms. And number 3, we have 1, 2, 3, 4, 5, and 6. So there are 6 terms, each one circled. And in number 4, we have 1, 2, 3, and 4. So 4 terms. All right, so that leaves us with finding of the degree. All right, so our first one has a degree of 1. So our second one has a degree of 2. Our third one has a degree of 5. And our fourth one has a degree of 3. All right, so pause the video here for a second. And I want you to just look through these and see if you can figure out where these numbers 1, 2, 5, and 3 came from based on the polynomial that I was talking about. Okay, welcome back. Okay, so hopefully you did some thought about this. Now here's how it works. How do you determine the degree of the polynomial? So the degree of a polynomial is the largest degree of each of its terms. So we do each term separately, and then we look for the biggest number. So for instance, in our first one, this term, which is a monomial, has a degree of 1. This term, which is a monomial, has a degree of 1. And this term, this constant term on the end, has a degree of 0. So the biggest of all those numbers is 1, and that's why the degree of the polynomial is 1. If we look at number 2, the first term has a degree of 2, the second term has a degree of 2, and the third term has a degree of 2. So the degree of the polynomial is the biggest of all those numbers, which is 2. If we look at number 3, the first term has a degree of 5, the second one has a degree of 4, and then 3, and then 2, and then 1, and 0. So that has a degree of 5 because 5 is the biggest degree. And number 4, we have a degree of 3, 2, 1, and 0. So the biggest of all those terms is 3, and that's why 3 is the degree of the polynomial. Okay, on page 3, we have some new definitions here. So if a polynomial is written so that the degree of the terms decrease from left to right, so the term that has the largest degree is on the left and the term with the smallest degree is on the right, and it keeps going down as you go from left to right. And the terms are in alphabetical order. We'll talk about that in a second. This just means that if they are tied with the same degree, they go by alphabet first. Okay. Then the coefficient of the first term is called the leading coefficient. Okay. So there's a couple words in here that are important. We have the leading coefficient. Okay, that's a definition in here. And then we know that a polynomial should now be written in this way so that it keeps decreasing from left to right. Okay, that's very important. So a polynomial with 2 terms is called a binomial. There's another definition here. So the polynomial has only 2 terms. It's a binomial. And a polynomial with 3 terms is called a trinomial. And then after that, we just say a 4-term polynomial or 8-term polynomial or whatever. So no special names. All right, so write 3x cubed minus 4x to the 4th plus x squared so the exponents decrease from left to right. So this just says reorder it the correct way so that the degree of the biggest term goes first. So here's our 3 terms, 3x cubed minus 4x to the 4th and x squared. Okay, these guys have degree of 3, 4, and 2. So we're going to write it with the decreasing degree. So our first term will be negative 4x to the 4th. Our second term will be plus 3x cubed. And our third term will be plus x squared. Okay, so that's part 1. And then it says identify the degree and the leading coefficient of the polynomial. So we already know our degree is 4. And then the leading coefficient is when they're all in order, which they are, what's the first number in front here? So this is negative 4. Okay. Now, if there was just x to the 4th in front, then the leading coefficient would be a 1. Okay. Number 6. Tell whether each expression is a polynomial. If it is a polynomial, then find its degree and classify by number of terms. So 9. So 9 is just a constant by itself. So this is yes, this is a polynomial. We're going to classify it by its degree first. It's a degree 0. And the number of terms is 1. That's a monomial. Okay. Number 2 here, 2x squared plus x minus 5. Is it a polynomial? This is yes. Okay. Classify it by its degree. Its degree is 2. Okay. And then how many terms did it have? It had 3 terms. Okay. 6 n to the 4th minus 8 to the n power. This is not a polynomial. Okay, to be a polynomial, it can only have integer exponents. Okay, where actually whole number exponents, not even integers. So a variable exponent is definitely not good. All right. So the next one, n to the negative 2 minus 3. This is no. This does not have a whole number exponent, so this is not a polynomial. When it's not a polynomial, we don't have to answer the second questions. Okay. And then our last one here, this is yes. Okay. And let's see, classified by its degree, it is degree 5. Okay. And the number of terms it has is 2. All right. So if we go back, we can write this in words here. So this is a classified by degree and the number of terms. So this is a 0 degree monomial. Okay. Our second one is a 3rd degree. Okay. And oh, I'm sorry, that wasn't 3rd degree. That was a 2nd degree. So a 2nd degree trinomial. Okay. And then our last one down here was a 5th degree binomial. Okay. All right, let's flip it over and take a look at the last page. To add polynomials, add the like terms. Find the sum of each. Okay, so if we want to add up polynomials, okay, then we're supposed to add up the like terms. And find the sum of each just says add them together. That's what it means. So what do they add to? All right, so here's the thing. When we're adding, there's nothing outside the parentheses here, so they don't really mean anything. So we can rewrite this without parentheses. There's no distributive thing to distribute. Okay, the only number out here is a positive 1, and if you distribute a positive 1, it doesn't change anything. And the same with back here. So we don't really need the parentheses here at all. You'll see this in the textbook because they're just showing you that we're adding this trinomial on the left plus this trinomial on the right. Okay? All right, so our job is to combine the like terms. So our like terms, I'm going to go through and circle them. Our first one is negative x cubed, and that will combine with positive x cubed. Okay? Those are term degree 3, so we'll do them first. But a negative x cubed plus a positive x cubed just cancels out, so they don't do anything. Okay? All right, then we have degree 2 and degree 2. So negative 2x squared plus 3x squared. So negative 2 plus 3 is 1, and put the x squared back so we don't write the 1. And then we have this next one, which is degree 1. So we put the plus 3x. And then lastly, we have this one on the end here. Constant term has no buddies either, so we put them down here. Okay, so we end up with a new trinomial, but this trinomial is only degree 2, whereas originally we were doing a trinomial at degree 3 and plus the trinomial with a degree 3. All right, so for number 8, once again, the parentheses don't matter. So we do 4x cubed plus 2x squared minus 4 plus x cubed minus 3x squared plus x. We combine them up, so 4x cubed plus x cubed will go together. This will make 5x cubed. And then 2x squared will combine with minus 3x squared. 2 minus 3 makes negative 1. We don't need the negative 1, we just write the negative part. So negative 1x squared just looks like that. And then we have the plus x that has no buddies, and the minus 4 that has no buddies. All right, so that's how adding polynomials work. You can only add the parts that are the same, so the terms that are like terms. All right, so subtracting polynomials is very similar. What we're really doing is adding the opposite. So just like when you did something like this, 5 minus 10, that's the same as 5 plus negative 10. We distribute that negative to the 10 and change it to adding. Okay, so we're going to do the same thing here. We're going to change these to adding. So the first one not going to change. Okay, 5 stayed 5. But instead of having subtraction, we're going to do add, and then we're going to distribute this negative to all the stuff inside of here. So this is going to make, instead of plus, it's going to say minus 3c squared, and then negative times subtract will make plus 4c, and a negative times 1 will make negative 1. Okay, and then we combine all of our like terms. Okay, so in this case, negative 2c squared minus 3c squared will make negative 5, negative 2 minus 3, put the c squared back. And then plus 4c will come down. And then we're going to put the minus 8 with the minus 1, the two constant terms. So minus 8 minus 1 will make minus 9. So negative 8 take away 1 is negative 9. All right? So this combines all of our like terms. Okay. All right, and then in our last one, we're doing something similar. So 5y squared plus 2y minus 4. We distribute the subtraction to all of the parts of the polynomial to make plus y squared minus 4y and plus 3. So 5y squared plus y squared makes 6y squared. That takes care of this one and this one. Then we have to put our y's together. So 2y and minus 4y will make negative 2y. And then we'll put our constant terms together. Negative 4 plus 3 are like terms, so that will make negative 1. All right, that concludes our notes for tonight. We'll have a classwork next time covering this. All right, so I'll see you in class.